Okay, this lecture is going to be a little bit different because this chapter is really solid gold, and all of this material in this chapter has a direct application to pretty much everything that we do as X-ray technologists. And so I just want to kind of walk us through the chapter and talk about the parts I'm really excited about. And then I also want to say kudos to everyone who contributed to the discussion board. I found y'all's comments really interesting. I'll just go ahead and reply here. I think that one thing that I'm really interested in seeing a development for is a more robust understanding of how DICOM works and how PACS works. So I would like to see people continue to explore ways to extract data from PACS files as a way to monitor patient exposure and standardized technique, as well as manage departments and workflow. But looking at this chapter, we'll just be kind of walking through these objectives. And he's going to spend quite a bit of time talking about this question here of why a 15% across the board increase in KVP is recommended. So he's going to kind of build a case here and give us lots of images of it. And this case is really kind of overwhelmingly proved by the literature, so I won't spend a lot of time on that. But we will talk about some of the details of how this kind of recommendation would need to be implemented. And then we'll look at exposure latitude and these kind of upper and lower limits and what are some of the things that we can run into with that, as well as we'll define signal to noise ratio, and we'll talk about overexposure and underexposure, because we can overexpose digital cassettes. It's just very difficult to do because we're talking about exposing it 8 to 10 times the amount of radiation that we would require for an exposure. And then really one of the best parts is talking about defining the continuing role of manual techniques. So I'm going to focus on that quite a bit. And then we'll look at these other things, because pretty much everything from 7 down really looks at just kind of practical, everyday things that we need to know if we're working with a digital system. So looking at this very first page, one of the things that I felt like was very important is in looking back to 2009, when we had finally kind of completed the rollout of digital imaging systems, the task group 116 of the American Associate of Physics and Medicine, this was really the beginning of looking at standardizing dose. They said that unlike film screen imaging and display and digital radiography is completely independent of image acquisition. So we need to keep that in the back of our minds as we're going forward. The next big point really can't be stressed enough, and it's on the very next page, that really there's just one very critical role to radiographic technique, and that is to ensure that adequate signal reaches the detector system, and that so that the computer algorithms can do what they do. So we're going to exploit that rule to continue to improve image quality, largely by messing around with KVP. And the reason for that is given here, that no amount of mass can compensate for an insufficient KVP. And so using two things is going to be what allows us to significantly decrease patient dose using digital systems. The first has to do with a preset definition that really it's the department managers and the physicists, the medical physicists, and the physicians that will make this determination. But it has to do with looking at the speed class of the CR or DR system. And so these, again, are made at the department level. But if you look at using a 400 speed class, it will allow for a more rapid acquisition of information. The image will be a little bit noisier, but we will still have adequate spatial resolution on most systems. And so what he suggests is begin with the 400. If the physicians determine they don't like it, then go from there. And that's kind of above our pay grade as workaday technologists, but it's an important thing to think about. The very next thing that he talks about is the high KVP and scatter radiation. So he's going to make an argument that there's not going to be any significant fogging that's produced by using a KVP that's higher than what we used to use for film. He presents a lot of pictures to argue this point, but at the end he just concludes that KVP levels can be increased by 15% across the board, and this conclusion has been reinforced now by sufficient research. There's plenty of stuff. There was even something published just last fall in the Radiologic Technologist, the Journal of the ASRT, and this is a very it's not a controversial point anymore. Initially, when the point was made, it was controversial, but this is agreeing across the board that when moving up from film, we can make this kind of change. So it is still going to generally reduce contrast, right? And so now we have to think about how the digital system is going to clean up that image. So that final point of controversy, he spends quite a bit of time talking about and gives us a whole lot of material evidence for how fine of a difference of KVP makes with contrast. Does KVP increases significantly change contrast? And then on page 572, he asks a really important question: does KVP in a digital age still control image contrast? It's a big question, and I want to point out that the very first sentence in this, I think, has some kind of confusing wording in it, but he says we can categorically state that KVP still controls the subject contrast of the remnant X-ray beam signal. Okay, now hold the phone for just a sec. He's not saying that KVP controls subject contrast. Subject contrast is an inherent property of the patient, right? But what he's saying is that we can control for subject contrast by manipulating KVP. But KVP is no longer the sole factor that we are using to control for subject contrast. So the final digital image, if we look down here, the final digital image qualities are primarily the result of computer operations, specifically the lookup table. So contrast now in the digital world is much more a function of the way that the lookup table functions, as well as further adjusting with windowing and leveling. Okay? So in light of all these considerations, he says the word control is too strong to describe the relationship now between KVP and digital image contrast. So we can no longer say that KVP is the controlling factor. It is a largely affecting factor that affects image contrast, but it is not the final thing, because we have these lookup tables, we have the ability to window and level these images, and we're going to be able to manipulate it, which leads us right into a discussion of exposure latitude. So exposure latitude is that margin for error, and like I've stressed a lot, digital imaging gives us a significantly larger margin of error for what would still be considered a passable image. Now, can we still burn out an image or overexpose an image? Yes, and the term for that is saturation. So saturation, like we talked about in the last chapter, can result from any exposure of like 8 to 10 times the amount required to expose the image receptor. Conversely, when we underexpose an image receptor, we can have quantum model. Everything from the quantum model to the saturation point is our exposure latitude for digital systems, because we can window between those two variables. So to kind of finally restate his point, on this next page, he recaps things and summarizes all the points made to this point, because they're very important. First of all, we're talking about increasing the speed class from 200 to 400, which are available for almost every system. And then we should no longer resist using the higher KVP. Now, we can see in Merrill's already there's been a significant increase in the average KVP, so this is no longer as controversial as it was when perhaps this textbook was published, but it's still a very important argument. And then finally, this legitimate fear of quantum model, we need to understand that. And then we also need to be able to look at CR/DR systems and how they inherently correct for overexposure, because this is how we have the social phenomena of a dose creep, where people are maybe unintentionally or intentionally overexposing patients because they know that there's such a high latitude for high techniques. And also, other people may not understand that the digital system is automatically correcting, and so there's no need to, often if we have an overexposure of a patient, there's no need to repeat the image. We can window and level to an appropriate image quality. Now he starts to get into some of the nitty-gritty of kind of really just common sense applications, like things that we still need to understand and make sure that we employ when we're using digital. So it is always important anytime we're using an AEC to make sure that we are positioning the part appropriately over the AEC, and then if there's image model, we need to increase the KVP for an AEC, which almost goes without saying because a lot of times they have little +3 or +2 type settings that allow us to do just that. And then anytime we're using a grid. To improve the signal-to-noise ratio, we're going to have to use a grid. And so he talks about, though, that now we can have artifacts unique to the digital system, like a moire artifact. And so that would be like false diagonal lines on the image that results from inappropriate sampling of things. It's basically like a quantum model that's unique to grid. And so it's going to be very important that we still are using markers and appropriate annotation. He continues on to talk about alignment issues, and so there's a need to center to the AEC. We need to center and use our grids appropriately. We need to have appropriate SID for the grid, etc. And then we also need to center the anatomy appropriately to the image receptor, because that can impact our edge detection and things like that. So he offers some examples of what that looks like. And then there's an important point here we don't want to miss on page 583 about overcollimation. He says, as a general rule, it's been given that 30% of the CR plate needs to be covered, at least 30%. Otherwise, the image receptor, the system may not completely recognize the exposure that we made. Here's the figures showing us exactly how we need to make sure that we're using our image receptors appropriately. And really, ideally, we shouldn't be doing more than a single exposure on any kind of exposure. All of these over here are going to give us some kind of field detection error that will result in a misunderstanding, misregistration of the image data. One of the final things that he talks about, like another potential kind of noise, would just be image retention, especially on a computed radiography system. And he just concludes that there's no practical time over which it can be assumed that a latent image will have faded away completely from a CR cassette. So basically, if we're not sure if a CR cassette has been exposed, before we run off with that cassette to make another exposure, we need to erase the cassette so that we don't have a double exposure or some kind of error. And so the summaries here is a really important section, and pretty much everything, again, that he talks about in the summary section is solid gold. You can take it to the bank. It really will continue to inform things moving forward. And so I would make sure that we review the chapter and the learning here, and that we all completely understand this material, because it's one of the most important chapters that we've read up to date. It's kind of brought a lot of key things together for us. All right, thanks, and bye.